Hello, friends. We are back with episode 143 of the R Weekly Highlights podcast. And thank you for your patience right off the bat. We normally get these episodes out on Wednesday mornings, but yours truly had a real life happen, so I needed a couple extra days. But in any event, thank you so much for joining us from wherever you are around the world. My name is Eric Nance, and as always, I am joined to share the latest and greatest of the R Weekly issue with my awesome co-host, Mike Thomas. Mike, it's November already. Can you believe it?
I can't believe it, Eric, and it's a little different for us to be recording on a Friday, but what better way to go into the weekend than our weekly highlights episode?
Can't said it better myself, man. Yep, I'm really looking forward to this. Got another great selection on tap here, and our selection was curated by the architect of one of our favorite art packages in the world, named Golem. That is Colin Fay, of course, and as always, he had tremendous help from our fellow RWiki team members and contributors like all of you around the world. So, Mike, you remember, I think we've both been doing a bit of traveling this year at various conferences, and a trend that I've seen, especially as I look at other people giving talks, presentations, is in the slide deck, it's not just putting a link to the slide. It's those fancy QR codes often at the bottom right corner or somewhere else that admittedly still is taking me some time to get used to, but now I have actually put one of those on one of my slide decks earlier this year. So I'm moving up on the tech stack, Mike. You can't hold me back now. But I always wondered, what if we find these QR codes in an image or a real-time video feed? Wouldn't it be really cool to decode that into R? Well, guess what? Now you can, because there's almost nothing that the R and its vast ecosystem cannot do. And our first highlight comes from Jeroen Ooms, who is, of course, one of the research or software engineers on the R OpenSci project, the architect behind R Universe that we have talked about in previous highlights. Well, he comes to us on his latest blog post here with the opencv package update on the R OpenSci blog. And if you haven't heard of opencv, this is the Google library for kind of image video recognition within a computing environment. So you can do things like facial recognition, picking out maybe words amongst a picture with words on it, et cetera, et cetera. Well, in the latest enhancement to the opencv R package, which again is part of the R OpenSci umbrella, you can now import and read QR codes. Yes, this is a thing, and it's awesome because now if I see these online, I can just boot up opencv and import them right away. And on the tin, basically, you get a handy utility function to do the QR code scanning, and you can do this a couple different ways. You can do with the QR_detect function, where you supply the path to an image. It could be online or it could be on your disk. And then it will find that QR code and decode it and then give you whatever the text is behind it. But it gets even better. Now, what I didn't know about opencv is that you can have a direct pipe if you're on a device that has a camera built in, typically a laptop, right? You can then have R wait for the video feed on that camera to boot up, and then you could literally show it a QR code, maybe from your phone or maybe from a printed document, and then opencv will take over once it gets that image and decode that on the spot. That is pretty nifty. Like that's some awesome magic there, and I know part of this is from opencv directly, but hey, the fact that R can do it, that is really nifty stuff. And in fact, when we get to the additional finds, I can tell you that there are others looking into this space that I think have some very interesting use cases for this. But there's certainly great support for this in opencv now. And then Jeroen's blog post at the end concludes with a reference to another R package that I actually do have some familiarity with called QR Code, which can help you generate QR codes in R directly. So you could actually put these two together, generate the code in R with QR code, generate that to an image file, and then as a validation of sorts, you could open that in opencv and make sure that the text is actually what you set out to be. So you could have double steps in this pipeline right away with a little creative magic there. So really cool to see opencv get another really important update. And I think this is something to watch out for, especially as out of convenience, almost everybody in their pocket has one of these. You don't see it on the audio here, but a smartphone at our hip. You just take a picture, get this QR code, put it into R, and there you go. So you can import that directly in your favorite R session.
So QR codes, how long have they been around for at this point? It's got to be like 5 or 10 years, but I feel like from a marketing perspective, maybe only in the last, 5 years ish, you see them on like every marketing ad poster ever. Right? They're on the table at the restaurant, right? For you to be able to see what the restaurant's menu is, which is pretty wild. There's some security folks out there I know who warn about QR codes because you don't know where that link is taking you until you scan it. It could be a malicious link that's going to download malware on your phone. So this is just my heed, some caution when you're scanning QR codes. But I think now, at least iPhones, they show you the link that it's taking you to, and then you can click that link before actually navigating to it, which I think is a nice little extra piece of security that helps prevent that particular situation from happening. So I thought that this blog post was really cool. It's another sort of niche look at just what is possible in R. I know we don't have R installed on our mobile devices, but with WebR, I'm assuming that we could potentially use opencv's QR scanner function to open the camera device on the phone, similar to how your own talks about opening the camera device on your laptop with R. And perform the same thing, scan a QR code. And I understand that this is pretty pointless because there's already software on everyone's smartphone that already does this, but it would just be kind of cool to be able to do that in R, I feel like, as opposed to whatever software is installed on your mobile device that sort of already does that. So some really cool functionality. This is a nice short and sweet blog post. To be honest, this sort of video and image processing stuff is not something that I deal with a ton on a day-to-day basis. So it's always very interesting to me to see what is out there. And I really appreciated your own also calling out that other package called QR Code that allows you to create, I believe, QR codes from R. So that's pretty wild as well. It's sort of like there's nothing that we can't do at this point. It feels like some days. So really cool blog post, and I think a really fun way to start off the highlights this week.
Yeah, and to show you just how new it is to me, this kind of new age of, like you said, either in marketing or in conference talks, throwing these QR codes around. I remember maybe a couple years ago as I started to see these, and I'm thinking to myself, wait, I see these, but how do I get this on? How do I get my phone to recognize it? So I'm searching the App Store for like these QR code scanners, and then silly me doesn't realize until a couple years later that if I just boot up my camera, if it sees the QR code, it'll automatically parse it. Like what? Oh, anyway, yeah.
I think we all had that experience.
Okay, maybe it wasn't just me because boy, I was like bewildered when this first came out. Of like, how do I deal with this? But yeah, it's become ubiquitous now in these mobile devices. I just remember thinking to myself, Eric, did you just waste that amount of time trying to find an app to do that? Oh, goodness gracious.
I think it was an accident the first time that I just happened to have my phone's camera open, pointed at something that had a QR code on it, and then a link popped up, and I was like, what is this? So you're not the only one.
Okay, well, there's strength in numbers here. No, thank you for reassuring me. But nonetheless, I did feel like I took a leap when, like I mentioned earlier, I think in my most recent presentation, or maybe it was my ShinyCon presentation, I threw a QR code at the end of the talk, and I used that QR code package to do it. So that was fun stuff. And you're right, like you, I don't do a lot of like real-time image video recognition processing. I know that's also a big topic in the deep learning space in terms of recognizing, text from images and whatnot. But certainly if I ever dive into this realm, I'll be giving opencv a serious look. And yeah, great to see get more substantial updates and hopefully even more in the future. And again, I'll take this opportunity while we are talking about the architect himself. Jerome, thank you so much for our universe. We are just really excited to see the progress that's being made. And I believe he's also looking into like the WebAssembly side of things as well in some of his recent updates. So we may have more to talk about perhaps in 2024 about that.
Yeah, I think there's some pretty cool stuff going on with binaries on our universe that potentially sounds like make package installation with WebR and WebAssembly a lot faster than it currently is, I'm guessing. But more to come. Who could predict the future? I don't know.
And Mike, speaking of things happening in the future, or maybe things that happen regularly, if you're driving around here in the United States in the wintertime, and especially as things start to thaw out in the spring, you may fall victim on our, traveling infrastructure to some of the worst things that can happen to you when you're driving on the road, and that are potholes. Yes, they can wreak havoc on your car if you are not careful. And apparently, this was an interesting topic from a data analysis perspective, because our next highlight takes you to the Steel City of Pittsburgh and looks at ways of analyzing some disclosed pothole data with modern modeling and time series principles. And so our next highlight comes from Connor Tompkins, who is a data scientist within the aforementioned Pittsburgh area. And he takes a very practical look at assembling this pothole data that came from an external site, I believe, provided by the government of Pittsburgh, if I recall correctly. And he takes us through a tour of kind of the EDA pipeline to a modeling pipeline with a key focus on time series, which is a world that I don't step into very much, but we'll just kind of walk you through some of the key principles here that he talks about. And a lot of this is leveraging packages that definitely kind of bridge the tidyverse to time series analyses and visualizations and modeling. And in particular, some of the packages that I've learned in this that are new to me are the FPP3 package, which actually accompanies Robert Hyndman's very well acclaimed book on forecasting principles and practices, the third edition. So this package has all the data sets from that aforementioned book, but also apparently wrappers to a lot of the other tidy principle time series modeling and visualization packages. So it's kind of like this somewhat of a blend of tidyverse yet with time series focus. So that was new to me as well. And so Connor talks through loading those packages at startup, importing the CSV with the pothole data, doing a little bit of massaging to get the periods or the sequences in place for the year and month combinations, because that's obviously a very key input as you start looking at trends in the number of reported cases of potholes that this CSV contains. And there are some very nice convenience functions to visualize this right off the bat with an autoplot method, a GG underscore season, and a GG underscore subseries set of functions. So you can start looking at facets or different colorings based on the year to kind of look at overall trends that you might see from a visual perspective, and being able to decompose this into the classical components of time series such as trend, seasonality, etc., to get a little more insight into kind of the patterns you might see across this. And as you might imagine, there are definitely outliers in this set as well. And you can kind of intuitively, if you lived here in the US for any amount of time, you can probably guess that most of those spikes in reported cases are likely going to occur in those cold months of the season. And it definitely shows in one of these trend plots in the winter of 2017 and 2018 in the city of Pittsburgh. There's a massive spike in reported pothole counts around January or a little afterwards. Now, that's great from an exploratory perspective. How about modeling? Well, you've heard us talk about quite a bit in highlights previous episodes about the methods of the tidy modeling approach or machine learning approaches. And one of the first things you can do is take your source data, split it up into training and test sets. So again, there's some easy ways to do that with the packages that have been used in this post. And then once you have that in place, you can turn loose with the modeling approaches. And again, thanks to some of the packages that are being used in this blog post, you can quickly fit, in this case, 3 models: the ARIMA model, exponential smoothing, and a linear model that incorporates seasonal effects, and be able to compare and contrast the model fitting metrics and the performance of these. Again, very similar to a tidy models type pipeline that we've been hearing about throughout the year and years before. And in fact, there's another package reference here called Fable Tools that lets you compute, in essence, a scoring metric to help benchmark these. And in the benchmarking, Connor sees that the seasonal component of the linear model tends to perform slightly better than the ARIMA and the ETS models, which again, very interesting insights there. Some, again, very convenient visualization functions to kind of see what that fit looks like and how it captures the actual data. And it can see that the LM seasonal model does do a pretty nice job of capturing most of that variation and those peaks and valleys of the trends that you see in the raw data and in the training set, I should say. There are some other treatments in this blog post on using cross-validation as another approach that might be able to be even more robust in the training and test splitting. But again, very similar to tidy models, you can get these partitions of the data, feed in the same modeling functions just on each of these CV sets, and then get those same benchmarks. And again, in this post, it looks like the linear model with seasonal effects is still performing better than the other two. Some of the theories that Connor has about why this might be is that the other models might be falling victim to overfitting in certain situations. So this is why it's always good to compare more than one model, because you might get some that are more susceptible to some of the spikes and variation, or maybe susceptible to a smaller data set than maybe some of these other modeling techniques. So really nice practical approach. There isn't a lot of pros in this per se, but it's great to see, if you've been curious from the time series perspective, how you could lift some of the principles you might be learning in other modeling machine learning approaches. You can take those learnings into the time series ecosystem and paradigm to do a really neat analysis like we have here. And I certainly wouldn't want to look at the data in my city for potholes, because they can be pretty nasty after the winter months. But if I ever had the data, I could use the techniques in Connor's post to really turn loose on just seeing where those spikes happen to be.
Eric, I don't think I'd want to see the data here in Connecticut either. There's some pretty rough places depending on the year and depending potentially on how much funding our public works has that particular year, how much time they have to go out and fix those potholes. But I remember my first introduction to time series and feeling like it was this whole different world of data science. And time series decomposition, I remember doing this by hand, looking at ACF plots, a ton of trial and error. And now it looks like the tidyverts, not to be confused with a tidyverse. So this is tidyverts for time series there at the end. That ecosystem of packages can do a lot of this work that I used to do by hand and through trial and error automatically for us. So a couple different packages within that ecosystem is the tsibble package, or tsibble package for sort of time series data frames, the Fable package for forecasting, and the feast package for feature extracting. That's feasts plural. And when building a time series model, one of the interesting things that I think you have to look out for that looks a little different than what you might be used to in classical machine learning is when you're splitting your training and test data, you likely want to make your test set the last 20% of your data chronologically, because you often need a consecutive time series to train your model on, not just randomly sampled points, because you have to be able to have that trend, that seasonality, that autocorrelation, those decomposed features of your time series available for training that model such that it learns those different time series components. And the last thing that I thought was really cool about Connor's post was that he structures his workflow in a way that looks pretty similar to tidy models, such that you can build sort of many models, right? Sort of programmatically, all at the same time. It has sort of a per or a workflows feel to it, where he's building, it looks like 58 different ARIMA models here, and he has the ability to extract the ones that are the best performers and plot their performance against the test set in ggplot in a really nice looking plot here at the end of the blog post. So for anyone interested in doing time series forecasting in a way that feels more maybe like that aligns itself with the tidy models sort of workflow, I would definitely recommend checking out Connor's blog post here. It's a great walkthrough end-to-end use case for a pretty interesting time series forecasting problem.
Yeah, there's lots of great example snippets here, and I really appreciate the convenience that this tidyverse ecosystem brings to us from the visualization right off the bat. You can quickly get to what you need to see in the trends and the variation that the model fits are presenting here, and it fits right into a tidy workflow. So if for those that have to make that transition, maybe for a new applied problem or a new domain, I think it's great to see this ecosystem, which I think started to really take shape, somewhat thereafter the tidyverse started to really take footing and the tidy models took footing. But again, want to plug Rob Heineman's very extensive set of resources for those that are looking to get started and getting to know about the statistics as well as the coding behind time series. His books are top notch, and they're a must read for anybody getting into the time series domain.
I would say, yes, Rob has been certainly the godfather of time series forecasting in R for quite a while now, and it looks like that's not changing anytime soon. So we appreciate his contributions immensely.
And moving along to our last highlight of the day, we're going to get back to somewhat the realm of visualization, but the spatial visualization route, and a interesting problem that arose in our last highlight author's domain that has an interesting solution for a quote-unquote off-label use of a well-known package. But let's dive right into this. And this last highlight comes to us from Mike Mahoney, who is a PhD candidate at SUNY ESF. And he talks about in this blog post about somebody coming to him with an interesting problem where they were trying to visualize a smaller spatial data set, but then adding some additional context coming from a larger data set, but trying to keep the overall aesthetic, the overall picture centered around this primary set without overloading the rest of the visualization on context of this larger data set that wasn't quite necessary. So it wasn't very obvious how Mike would tackle this. So that's where this blog post takes an example inspired by this and looks at this. So the example starts off with a visualization of the county regions within the state of North Carolina, which you can quickly get with the SF package and ggplot2. Very easy to import that shapefile, ggplot it, you're off to the races. Now, that may be not what the example is interested in. There may be a particular county that has some various metrics. You could name anything you like, and you want to center the visualization around that. So he looks at Johnson County over in NC and does a nice little simulated look at superposing points on that county plot. And that's great, but what if there was additional context that needed to be put into that one county look in ggplot2? But if it came from the surrounding counties, you might just by default expand your visualization to account for the rest of the boundaries in that state. But then you've got the whole state, right? That's not what you want, because you may be only interested in the parts immediately surrounding the Johnson County. So one approach that he talks about is using the expansion function within a scale continuous call, which was new to me. I wasn't familiar with the expansion function in ggplot2 before this, where you can kind of give additional limits to put the plot around. Now, this may not be what you want in the long run, because that is doing the scale as opposed in relation to the larger data set. But what if you want to still keep that scale in the principle of the smaller data set? There are some approaches that he talks about in this post, one of which is simply filtering out the data set, the larger data set, to exclude any of those observations that were too far away from this immediate county that's being visualized. That may work for certain cases, but it's, in his words, kind of more reducing the problem, but it moves the center closer to the center of the layer we care about, but it has similar issues of adding a bit too much around the plot that's not as relevant. So comes the off-label usage here. Well, in ggplot2, if you weren't aware of it, you can actually get the components behind the plot using the ggplot_build function, feeding into that a plot object. This is where you can kind of get, like I said, behind the scenes, so to speak, of what's making up that visualization from both the data perspective and also kind of like the aesthetics around it, such as the different layers that you put on top, the different coordinates that are being used in limits and whatnot. And from there, after extracting the ranges on the X and Y axis of the base plot, if you will, from the very beginning, he could then take those limits and then supply them in a subsequent call to ggplot and use those instead that were built from the smaller model into a smaller visualization into the somewhat larger visualization. You can tell whenever I try to describe a visualization on this podcast, I might have a little trouble describing it. So definitely look at the blog post after you hear this to see the finished product. But he does caution that this isn't exactly a method that is advertised as a way to kind of merge these contexts of a smaller, primary set of visualization data with this larger set without doing some additional, more classically talked about tricks here. This is taking the innards of an existing plot, taking information from that, and then putting it into the customization of a second plot. Now, what's nice about this as well is that ggplot build is an exported function. This isn't a case of him going into the infamous 3 colons to get into a hidden function of a package. I think there's a reason that this is exposed in the main ggplot2 kind of UX, so to speak. So maybe off-label is a bit too strong here, but at the same time, this is a technique you don't see talked about quite a bit, but hey, it might pick you out of a jam, so to speak, in your next visualization adventures, whether it's spatial or other types of visualization. But again, a practical example. It is verified to work with ggplot2 version 3.4.3 at least, and hopefully it stays that way for his sake in the near future. And apparently there are some comments in the blog post about additional methods to do the coordinate boundaries as well, which maybe will spur on some additional discussion. But definitely an interesting use case from the trenches and hopefully helpful to all of you in the spatial visualization world that encounter a similar situation.
I haven't used the expansion function from ggplot2 either, I don't think, before. But what I have done, though, is create a ggplot object and then extract some information from that object before rendering it. And okay. Mike employs the ggplot_build function, as you said, Eric. And I'm interested, I guess, to see how the output from this function would differ than just creating the plot and assigning it to an object, which would be a list object, as we know, and then accessing what's in that list object, all the different components of it that make up that ggplot. So I'm not sure. That's something that I'd like to explore. I don't know if you know that, Eric. Taking a look at the ggplot build documentation, it says that ggplot build takes the plot object and performs all steps necessary to produce an object that can be rendered. And the function outputs 2 pieces, a list of data frames, one for each layer, and a panel object which contains all information about axis limits, breaks, etc. So it sounds like if that list is just sort of 2 pieces, to me, from my recollection of ggplot, I think a ggplot object list is a lot longer than that. There are typically, I feel like I see 9 or so elements to that list with a lot of nested items underneath that. So maybe this ggplot build returns something that's a little bit easier to dive into the internals of. But I'm interested in seeing how those two outputs differ. And as you said, Mike worries about how stable this approach is, but I don't think there's anything necessarily wrong with it either, right? These are exported functions that we're working with here, and you want to do a little bit of customization, and you found a way to make it work that's, in my opinion, not too hacky. I've written a lot of code that's a lot hackier than what Mike has in this blog. So I think this is potentially a little bit of a theme for folks who do a lot of data visualization. I'm thinking of Plotly now specifically. I have a client who has a lot of stuff in Plotly that they're trying to customize, and sometimes you've got to dig into the internals of that list object to find that element that you want to modify or customize, because you want to show something in your plot that differs than what you get out of the box. And it takes a lot of digging and diving and wrestling with the object and finally trying to find that nested list element that you actually want to modify. So to me, that's somewhat part of the game when you're doing some of this advanced data visualization, unfortunately. So I think this was a great walkthrough by Mike on how to do that and how to find a solution for his particular use case, which was really interesting. And it's a nice little plot he has at the end of this blog post. So definitely one to check out if you are a data viz head and looking to add some particular customization to the ggplots that you're creating.
Yeah, you're mentioning going into the innards of a plot object. Yeah, I've definitely been down that route, especially in the early days when I was trying to stitch multiple plots together. These grob objects that come out of ggplot2. Yeah, there's lots of interesting things you can do with that, which are now made easier with packages like cowplot and other patchwork, I believe, that Thomas Wynn Peterson has authored. So there's lots of conveniences in the ecosystem to make this easier. But yeah, sometimes you just got to get into that metadata, get into what you need, grab it out, use it somewhere else. So I've been down that road as well. And yeah, you mentioned Plotly. I've been doing that as well. I think I spent almost 3 days, give or take, on trying to replicate in Plotly. This is definitely not spatial, but if you're in statistics, you often will, to educate people on how, say, the normal distribution works or another distribution, you do the density curve, and you can do like the CDF or cumulative distribution and see where the cutoff of like the 97.5 tail versus a 2.5% tail, showing that visualization. In ggplot2, there are really easy ways to do this. And in fact, there are some solutions in the R Graphics Cookbook, second edition, that's on my bookshelf, that talk about plotting statistical distributions. In Plotly, you can kind of do that, not easily though. And I spent a lot of time going down the rabbit hole, getting the Plotly plot object to get the data back out to do the shaded region based on a probability level. And yeah, that was not for the faint of heart. So I may just end up going back to ggplot2 for that one, to be honest. But in any event, yeah, I've been down those roads before. But I do think, to your point earlier, I think ggplot build is basically a way that the ggplot2 authors know that sometimes you want to get to the internals of it, and this is going to give you a slightly easier way to navigate to it. But other than that, yeah, I haven't had a lot of usage of it recently, but it is nice that those conveniences are there. As we said, it's exported. It's not like it's being hidden anywhere. So yeah, if you need to dive into the internals, yep, you've got your way to get there.
It's a big world out there in data visualization land.
Never a dull moment, and you can never know everything from it. But I think the process of exploring it is actually half the fun right there. Speaking of fun, boy, the rest of the issue is jam-packed, a lot more fun and exciting content to level up your R knowledge. And we'll take a couple of minutes for the additional highlights here. And I'm going to go back to what we talked about in the first highlight with the opencv enhancement for QR code scanning, because there is another link in this week's R Weekly issue about other ways that you could use QR codes quite creatively in your R adventures. And Matt Dre has an interesting blog post called Unlock R Functions with QR Codes Now, this may not be the most typical use of a QR code, but he has an example where what if you had a function that would only give you the right answer or the right output if you showed with it the QR code instead? Kind of like a authentication thing, perhaps. So there's a nice snippet of code that Matt Dre goes with. But apparently, in subsequent discussions, this is what really got my attention. You could use this functionality, this kind of piggybacking a function to look for a QR code and then go to somewhere afterwards, to build your own multi-factor authentication scheme in your R session. You know where that could be? What if you have that app in WebAssembly? What if you need a two-factor authentication baked into your app? You could have the user scan a QR code to get to the rest of the app potentially with this. Is this overkill? Very likely so. But hey, it's nice to know that things like this could be possible. So I had great fun reading about that the other night and thinking, yeah, if I want to get creative with QR codes, I got some avenues to pursue here.
I don't know what's worse, like trying to wrestle with some of the vendor authentication APIs, or to try to roll our own two-factor authentication using QR codes. Eric, not a fun land to live in. Once you get it and solve it, it's an amazing feeling. But man, the hours that I have spent wrestling with multi-factor authentication for particularly the Microsoft ecosystem is a lot of time I would love to have back. But that's a rant for another day. A really cool blog post that I found as well is one from El Salmon called Useful Functions for Dealing with Object Names. So you may be familiar with like the set names or the names or the unnamed functions from base R and stats and utils that you get sort of out of the box with R. But there are some really interesting Rlang equivalents. And there are also some functions in teststat that help work with named objects that I had never realized. That there is a teststat expect _ named function for testing if an object is a named object, which I think is really interesting. I could come up with some use cases for that probably today for some of the packages that we have. I think that's really interesting. And in terms of some of these interesting differences between base R and the equivalent functions in Rlang, I'll just point out one. If you have a length 2 vector that is not named at all, the names function from base R will just return a single null response. And conversely, the names2 function from Rlang would return 2 empty strings that are as long as the vector. So when you think about writing tests within your code to see if a function or an object is named or does not have names, or what those names are, trying to ensure that your code is working as you expect it to work, I think this names2 function could be really interesting complement to use as opposed to the names function from base R, depending on your use case. So again, this is Mael's dive into some useful utilities in base R that I always really appreciate. So thanks to Mael for putting this blog post together.
It's been a pattern recently in her, continued learning on some of these either internal functions or from other packages. There is a lot more than meets the eye with Rlang, right? I mean, we typically think of the non-standard evaluation constructs and everything. Boy, there's a lot of nuggets here that I think are very useful from just a general package development engineering perspective. So, yeah, I really appreciate Mel documenting yet once again some maybe somewhat hidden gems in these additional packages, and again, also internally in your default R installation that we can all benefit from. And where else you can all benefit from, it is the rest of the R Weekly issue, and you know where to find it. Hopefully you know by now, but if you don't, it is rweekly.org. You can find the link to this issue and all previous issues as well. There's a lot of terrific content that we've had throughout this year and, of course, the years before, for you to level up your R knowledge in many, many different domains. And we also love hearing from you out there in the community. The best way to get a hold of us, you got a few ways actually. One of which is to utilize the contact page in this episode's show notes in your favorite podcast player. You can also send us a fun boost along the way if you're using a modern podcast app like Cast-O-Matic, Fountain, or Podverse, many others in this space. That's a fun way to get in touch with us directly. And if you want to keep your podcast player, hey, we understand they're a personal choice, and a lot of us will stand by the podcast app we used like years ago. So we all get that, and you can boost us directly on the podcast index if you wish to do that instead. We'd love to hear from you. And in terms of giving value back, another great way to do that, just share the word of R Weekly. Share it with your friends, share it with your colleagues at your day jobs or your other organizations if they're looking to see what's happening in the R community. I'm biased here, but I think R Weekly is probably the best place to go right off the bat. So sharing the word about the R Weekly project and the podcast is another terrific way to share your value back to this humble little production we do here. And speaking of humble, I try to keep humble on social media, although sometimes I'll have some epic rants from time to time. But you can find me at our podcast, at podcastindex.social on the Mastodon ecosystem. Also sporadically on the XE thingy at the Rcast, and also cross-posting my thoughts on LinkedIn from time to time as well. And Mike, where can a listeners get a hold of you?
Sure, yeah. I would point them to either LinkedIn or you can find me on Mastodon at Mike_Thomas at Fossadon.org. I do want to shout out, I received some feedback on the podcast recently from a client and friend. So AJ, if you've made it this far in the podcast today, thank you for listening, and just wanted to give you a quick shout out. We appreciate the feedback.
Oh yeah, awesome to hear that. Yep, I do get from time to time some people at the day job saying, "Oh yeah, you do that podcast thing." Yeah, kind of. I told this story once before, but I had a colleague that was at a Denver company that just became a father a few years ago, and he said that my voice was able to put the kid to sleep. So win-win, I guess. Anyway.
Oh, that's awesome. Hey, whatever works.
Any positive feedback, I'll take it at this point. So whatever works. And trust me, you're talking to the dad here that had to drive their kid around the whole city to get them to sleep in the car and literally not stop until they woke up. So the struggle is real for all you parents out there.
Oh, my wife did that yesterday for an hour and a half, just driving around town.
You have my sympathies, but best of luck. Hopefully it gets better. But in any event, we hope that you have an awesome start to your weekend after listening to this episode. And hopefully we should be back at our regular time next week. But if not, we'll find us at some point. But until then, like I said, check out rweekly.org for the current issue and all the previous issues. And we look forward to speaking with you all again with more great R Weekly content next week.